All right, you can't tell it, but we're just a couple of blocks from GTC,
Literally.
Luke. And I've had you on a few times. You're now Kamiwaza. First, two congratulations. First, congrats on the funding. That was a big deal.
That was a really big deal, actually. Uh, Colorado company, it's not the easiest, man.
No,
Seriously,
it's not. It's not a Colorado AI
like
company.
Colorado AI company, people are looking at me sideways, let me tell you.
Like the first thing, like, are you guys seriously in Colorado? It was the part of the pitch deck, like, seriously, are you seriously in
That's
Colorado?
kinda how it started every time.
Yeah. So congrats on the funding. That is a big deal, especially even with AI. Everyone has really great ideas. I actually talked to a guy at the Beyond CUDA event yesterday that absolutely is following in your trails and his idea and the challenges. So I just saw Madden will probably post a picture somewhere here with his Apple goggles on, more than likely coding,
He was absolutely coding, yes.
more than likely coding. But the second piece of congratulations is planned obsolescence. You got scared. What about a year or so ago? You said Nvidia is out just making sure that you cannot use the 100,000 GPUs you're buying today. You won't be able to use them a year and a half from now.
Th They had to do this. Yes, thank you, by the way, on both of those. And if you just ran the math for the TAM that they're filling into, the fact that they were a $3 trillion company, meant it so you weren't buying this on a normal depreciation cycle. You couldn't buy an H100 and expect 5 years, 6 years, 7 years like you would try to eke out of a hard drive. To have that level of volume, to have that level of revenue, they have to force their customers to buy. Typically, it looks like a 12-month cycle, 18 months on the long end, the most expensive CapEx ever in IT, and they're doing it, and everybody skewered me, and I mean everybody, I think that one post on LinkedIn got to almost 400,000 impressions, like, it was one of my widest pushed out ones ever, and it's because everybody's thinking it's just a hardware game. It's a hardware matched with software. ARM processors, unlike x86 processors, have a reductive set. So from one generation to the next, if you want a feature to be added into it, you have to have a net new chip. To have that net new software they've written now to be able to access it. That means the previous version literally can't utilize that software for that new feature. And they're marching that obsolescence. And today,
He literally said, if you have Hopper chips, the H100s, you cannot give them away
give them away.
once Blackwell is fully up to value.
Yeah, he said 40x, I think, was the
He
performance
had,
chip.
44 per watt,
Yeah.
was 40x the performance. So, me and you have gone back and forth on this quite a bit, because H100s are the workhorse.
They literally are.
People and this I'm having trouble wrapping my head around just how much better Blackwell is because people are doing amazing things with H100s still. And to get 40x the performance, I think one of the first questions is the demand there to get to fill up all of those tokens.
I see it as, um, I see it as paramount. The H series was so powerful, both from its token throughput, but its thermal throughput. It
Mhm.
is literally a power hog from a heat and dissipation perspective. If we're the same wattage, you could get 40x more power. Means a typical enterprise with a typical data center, even with a high power output, can go from barely able to get enough tokens and enough processing to start to transform to now getting more than enough power, literally both tokens and efficiency, put into that particular facility. And that's a paradigm change I think people are going to find out.
And I think one of the things that was really interesting, he gave a contrast on how much inferencing is needed for traditional foundational models. I think the example he gave was like 400 and something tokens for a basic request that returned a wrong result
Mm.
versus a reasoning model, one of the more modern models that, R1 for
Yep.
whatever reason
Yep.
has made famous, uh, 8,000 tokens.
Mhm.
And, and again, to put this in context, uh, a human, I think, reads at a roughly about 100 tokens.
No, no, it's
No,
like 25.
yeah, so 25 tokens,
Yeah.
a second. So that is quite the bit. That's a lot of data.
Oh, yeah, yeah, yeah.
So one of the other thing that I wanted to kind of point on before we get too off into the AI world, I'm trying to wrap my head around another comment that he made. The 1 megawatt AI factory
Mhm.
data center is a small
Yeah,
AI factory.
yeah.
The now both me and you have traditional data center history. 1 megawatt data center used to be big,
That used to be a big old facility. Yeah.
and it's going completely against the grain that everything is getting smaller and smaller. So multi-year investment to build a multi 1 megawatt data center, now a multi-megawatt data center, is a significant investment and takes quite a bit of time. But H100s obsolete in 18 months.
Yep.
As people are thinking through their AI factory and keeping the lights on in other areas, how should they be thinking about consuming? Let's pick on your product, Kamiwaza, without TLDR. You guys have an on-prem plate.
Mhm.
How
And
how do
private
I
cloud.
in private cloud?
Yeah.
And how do you plan for that when I can't even keep up with the GPU pace?
I think, um, I think the market conflates training and inferencing a lot. Yes. And at 1 megawatt, the amount of inferencing, the world's largest company could automate probably all of its operations. Like, real easily. I mean, um, we're talking a set of 4 Blackwells, 8 8 8 GPUs per server, 4 of them. You're probably in at what's called FP4, so the lower context, and lower capability, from a floating point that you can do on those NVIDIAs. You're probably talking somewhere in the north of 1,000,000 tokens a second on a reasonable size model. That is a tremendous amount of generation, knowledge processing, knowledge capability. And, a company the size of, like, I'm just throwing out there, FedEx of like 500,000 people, figure 100,000 people in that 500,000 are doing knowledge work. You're probably talking that level, of knowledge work is probably that million tokens a second. But imagine 24/7, 7 days a week, always running, never getting tired. Like, it's crazy.
So that actually is super helpful context because a lot of these large SaaS providers are trying to sell me AI, not agents, but AI assistants,
Mhm.
yesterday's technology,
Yeah, literally.
for $35 a user. So the math to get to transformation becomes actually pretty easy. And I made this argument yesterday that the math around AI inferencing and the investment in AI and the refresh cycle, the depreciation schedule is pretty easy to. That's
It's
that's pretty easy math.
It is, especially and sadly, but especially when you start mapping it to, and it doesn't have to be directly human, but what's a, FTE mapping?
Mhm.
And if your average employee FTE 125,000 and an equivalent work unit is about 125,000 on the compute, you could say, all right, well, if it costs me $1,000,000, that's 8 FTE equivalent. Is there an ROI on there?
Right.
And it does make sort of the math easy to process out. But you've touched on it multiple times. On the inferencing side, the feasibility, the output of this, and the capability to get massive ROI is not a megawatt. It definitely starts at 10 kilowatts, maybe 50 kilowatts is a nice little sort of starting. Still big, actually, back in the day, that would have been, quite a few 5 kilowatt racks or 10 kilowatt racks. But nonetheless, the increment to start is reasonable. Now, if you're an organization, and there are a few of them, but if you're an organization that needs training, that's a whole different story. And I mean, a megawatt data center, they're talking about 670 kilowatt racks.
Yeah.
So nearly a megawatt a rack.
Almost a megawatt of
Rack.
rack.
Yeah,
That
that is
we're at supercomputing 24, and they were talking about the 500
Yeah.
let me like
Kilowatt.
kilowatt rack and the 600 kilowatt rack. It is here, especially with Blackwell. So as companies are thinking through kind of this planned obsolescence, how should they be thinking about the platform layer of this equation? Like, how do I normalize the interface when the
Mhm.
underlay is constantly changing?
Yeah, I think that's the key. So, obviously, that's our big bet. We think abstracting out the software, in our case, we call it the orchestration layer, that all of these agents, all of these apps are actually going to plug into. They're going to plug in three key ways. They're going to plug into an API, they're going to plug into an SDK from a programming, and they're going to plug into MCP, Model Context
Mm.
Protocol, the ability to reach out and receive tool and function calls. And when you can abstract that and you can attach the data into that abstraction, and then you can attach the inferencing to accomplish that via that abstraction. So now those third party apps and agents can just call in. You now have an orchestration layer at the software, and then the hardware can be swapped out. At the moment, absolutely bang for buck, most tokens per second, Nvidia has the market. And they're probably going to own the market on training for a while, but let's set that aside. On inference, this is just amazing. But I wouldn't count out Intel, I wouldn't count out Qualcomm, I wouldn't count out AMD. We're both at an AMD conference yesterday. Uh, from a watt, from a thermal load, from a tokens per second, from a cost, as you get into those more reasonable 50 kilowatt, 100 kilowatt deployments for the large enterprise, there's gonna be a lot of competitors, and you're
And
gonna wanna be able to swap that out.
and the after you left there, it talked through. There was a few more, not even companies, doing hardware companies, people doing kernels, people doing compilers
Mhm.
that are not CUDA based, and I think in the noise of all of GTC, Nvidia's $3 trillion stock price, we lose sight that there are still plenty of companies doing
Yeah,
inferencing on CPUs.
yeah, absolutely.
Like, it really does depend on the use case, and the importance is to develop the muscle to move processes to agents and normalize that development reliably.
I'll break a little news right now. We just finished testing, R1 on a Xeon 6, and it runs just fine.
I've heard that, and just as long as it's enough RAM.
So you load up about a little over 500. So you can do it with 512 easy. If you get above 512 gigs of RAM, you can load it right in. We're getting something like 50 to 100 tokens per second. So that's a full reasoning model, full capability, processing at 4 to 5 times what a human can do at the edge on a standard Xeon 6.
So you imagine the performance you get on a low end GPU on
Yeah,
a
absolutely.
Jetson or something
Yeah.
on one Blackwell.
Yeah. Well,
Uh,
they have that. That's that new DGX station they just
yeah.
announced in the Mini. Yeah.
So I'm super excited about the future. This podcast will probably be stale as soon as we really release it.
It probably will.
What are Talk to me about what is your most exciting customer doing?
Um, my most exciting customer. So there's one that we both know about. They are transforming 30 or 40 enterprise data feeds. The biggest sort of a highlight for a podcast. They're transforming 30 to 40 data feeds, and they've moved the system of record. The main system these larger enterprises, especially manufacturing enterprises, utilize, that base system of record that they have other apps on, that they have to get all their data, and they have to get that data normalified so that it is the system of record. They've announced that they no longer want that system of record, that AI, since they're now having all their data feeds stream right through AI, the need for that one system of record doesn't make any sense, because as the data is going through the AI, if a CFO wants a report, they can generate the report on demand. If the CFO wants a Monte Carlo simulation of costs going down, goods going this way, failure, they can do that absolutely on demand.